Another example, which use the same set of the curves, the y equals x squared, y equals 4, and x equals 0, revolve about the line x equals 2. Draw the figure. Or graphs in one area. So the order pair that's the graphs intersection will be 2 and 4. This is the curve y equals x squared. This one y equals 4. And the vertical line here is x equals 0. This region rotate about the line x equals 2. So from the scale here, so this is the axis of revolution, which is x equals 2. So rotate about this curve or this line. We're going to start with the slicing technique. We know the axis is the vertical line. So we perform the cross section perpendicular to the axis of revolution. Let's get rid of this, get out of the way, and put it up here. After we see the line or the bar, this bar located on the y-axis, we name it as the position y. That means we know if we do this slice, if we use the slicing method, it will be the problem with respect to y. So make a list, make a note here, the thickness or the width gonna be delta y or dy. The y value will be bounded by the lowest y, which is 0, and the highest y would be 4. Y is from 0 to 4 as the interval of integration. And then next, if we perform the rotation, you will see the solid. For this slice, if we form the watcher, I'm gonna make it clear that the vertical line here is the axis of revolution. You can see the middle part is empty. Make a note. This is about the washer. For the washer, we will need the outer radius and the inner radius. Okay, for the outer radius, measure from the axis of revolution to um, the furthermost curve, and the inner radius from the axis of revolution to the closest curve to it. Starting with the outer radius, from the axis of revolution to the furthermost of or the outside most of the disc or the washer, sorry. So this is the outer radius. Put a note, the outer radius, since this is with respect to y, you measure the right function minus the left function. And the right function would be the line x equals 2 or the axis of revolution minus the left function, which is the end part of the washer or the line x equals 0. So the outer radius is 2. So 2 is the axis. This case, the axis is on the right of the graph. So this is the line x equals 0. Now, we're going to find the inner radius. For the inner radius, the measurement or the distance from the axis of revolution to the closest curve to it. So the inner radius from the axis of revolution or 2 minus the closest curve, which is the curve y equals x squared. Let me redraw this real quick. We do this. And the curve that we use, which is the curve, this one is y equals x squared. Recall if we do with respect to y, the function has to be rewritten as x in terms of y. So y equals x squared becomes x equals square root y. The inner radius is the difference of the axis of revolution function minus the closest function, which is square root y. We get them all as we have the thickness, the interval of integration, the outer radius, the inner radius. Put them all together for the volume of revolution formula. For the watcher, gonna be the integral pi, the square of the outer radius, subtracted by the square of the inner radius, multiplied by the thickness, integral from 0 to 4. And the quantity 2 minus square root y all squared that give you 4 minus 4 square root y plus y and subtracted from the value 4. Now we get the simplified integrand in the form of um, 4 times square root y, which is y to the power 1 half, minus y with respect to y, and find the antiderivative. The answer is 40 pi over 3. So this is a slicing technique. Next, we're gonna do the shell technique of the same information graph, same information of the curve. Same graph, intersection point 2 comma 4, the region, and the axis of revolution is x equals 2. So this is the axis. And this time we're gonna do the shell technique. The shell technique, the partition or the bar is parallel to the axis of revolution. This bar, the position x, as you see that is laying down on the x-axis here. So we have the problem with respect to x. If we use the shell technique, that means the thickness or the change of the the position gonna be with respect to x or the delta x, which is the same as dx. The interval of integration, if you move the bar to the left to the right, the lowest x is 0, the highest x gonna be 2 because that's the end of the graph. X is greater than or equal to 0, less than or equal to 2. When you perform the shell or pretend like this bar wrapping around the axis of revolution, we're gonna need to find the radius and the height of the shell. For the radius, recall we measure it from the axis of revolution to the bar or to the position of the bar. So axis of revolution to the bar. So this is the R. Put a note on the side. So then the radius or the R equals, this time the axis on the right of the bar. That means the axis will be first and then subtract by the position. I'm going to put here, this is the axis and this is the position of the bar. Next, we're going to find the height of the bar. The measurement to find the height based on our information, we can see the the highest point of the bar is the horizontal line y equals 4, and the bottom of the bar uh, located on the graph y equals x squared. And this is with respect to x. We do not have to rewrite the function in another form. So our height will be the top part, which is y equals 4, minus the bottom part, which is y equals x squared. So I'm going to put a note here. This is top minus bottom graph. And nothing we can simplify at this point for the prep information. Next, we're going to do the volume or set up the volume. The integration from 0 to 2. The shell, we're going to need the circumference, which is 2 times pi times radius, multiplied by the height, multiplied by the thickness. And 2 pi as a coefficient from 0 to 2. The radius is the quantity 2 minus x. The height is the quantity 4 minus x squared. The thickness is dx. Simplify the integrand by expanding this product to get the polynomial 8 minus 2x squared minus 4x plus x to the third power with respect to x. The antiderivative 8x minus 2 over 3 x to the third minus 2x to the second plus 1 over 4 x to the fourth. Evaluate from x equals 0 to x equals 2. And after you substitute both lower and upper limit, the answer should come out the same as the previous method, which is 40 pi divided by 3.